Okay, here we are again in the workshop. As you can see on the bench is Fergus's engine in a test stand. I've still got a bit of work to do to it. It's not the most, it's not the nicest of fabrications, but it'll serve a purpose. I've got to put some brackets on it to support the temporary oil tank, and also to take a sprocket, a remote sprocket. Because I'll be using an electric start to get it going. But watch this space, and we'll come back to it in a few days' time when I've got the sprockets made, etc. And we'll make an exercise. I'll have to machine this plate. It's a nearly 8 inches square. I've got to get it down to 6.778 or thereabouts. For the 33-2 sprocket, which I'm about to make. Okay, well here we are in the workshop again, about to make a sprocket. First thing I have to do is to set the machine on and zero the axes, etc. That's the machine on, and it's saying it can't connect with the USB, so we'll try again. Enable auto change. I'm not going to, because there's only one tool involved in this job, so I'll cancel that. I'll cancel that too, we don't need that. It says OK to reset ATC. Get rid of that as well, it comes up every time. OK to reset, yes. OK, reference Z now, I'll say yes. Actually, I need to change that over to here, and you'll see that's the Z referenced, and I'll reference all of them before we start anything. And there you see the machine is putting itself in its reference position. This is my way of finding the zero for this machine, for this next part of the program. This is a super precision chuck, 3-jaw, and this center point was ground on here, and I use a laser to shine directly on the top of here to load. To move the table in the X position, I press the X on this, and there you see that's there. That's roughly in line with that, so I'll go to the Y. Oops, and I've just hit the limit switch. Never reset that. Y, and then I'll go in and switch on the laser, and then you can see the red spot is almost on the top, and a tiny bit. And I reckon that's pretty much centre there. So we'll set the zeros. So I'll go to my X and Y axes and zero them. That's 0 for the X and 0 for the Y. I've now got to zero the Z. To do that I have to insert the tool. So we'll take the laser out. A nice feature that I have on this machine is the power drawbar, which makes life a lot easier. I can't unfortunately show you this working unless we can get it from here, possibly. Put a pen under there, some support. Yeah, I might be able to see it working there. Press the button and it releases. And the tool for the job is a 6mm end mill. Here it is. it in. Simple as that. No messing around with colours. Now, one thing I forgot to do when I wrote the program out, or not wrote the program out, but when I got the G code out or made the program up, I put the reference for Z0 at the top of the material, and I think I included the height. I haven't got quite got the height right. I need to set the 0 6mm above the table, basically, is what I'm trying to say, to allow for the thickness of the material. So we'll see what happens when we see if we clatter a tool up or break something. It'll always provide a bit of interest and a few laughs for viewers. Okay, I'm taking this as close as I can. I'll stop there, and just using a piece of paper as a feeler gauge. You can see it's the ticking sound you hear is just the stepper motor taking this the tool down very, very slowly, 1/1000 of an inch per click, I believe, maybe even less. It's still not there. We've still got a fair bit to go. Yeah, still more. It's getting closer now, not much more. Still a good way. It could be that I'm going the wrong way. It's getting there. It's getting close. And it's just about there now. In fact, I'm going to put the camera down because I don't want to hit the work, so I'll just put the camera down, and just to check that things are not going to do anything catastrophic, I'll take the tool out, and I'll take the adapter or the fixture out of the chuck, so that I've got a good chance that there's no collision, and I'll be able to see roughly whether it's looking right. So I'll do that now. I'll have to take both hands, unfortunately. As you can see, I've got the machine cutting air. You can't actually see the spindle rotating, but it is. It's doing 1500 RPM. It's a very nice, quiet machine. The humming in the background is a compressor, which I'll turn off once I get going. And you can see the rotary table there. It's just clicking around slowly. And you can see there's some movement of the table. The main thing to me is it's about the right height. By the time I put the tool in there and the work, it looks as though it's not going to create any massive problems. So I'll now go ahead and put the tooling in on the workpiece, and we'll start the machine off with coolant, etc., and see what happens. Well, we had a bit of a nasty with the last attempt. If I show you that, the teeth at that side look okay, but at this side they're virtually non-existent. And that was due to a very small step on the outside jaws of the chuck that's being held in. Actually managed to grip the tool, the job eccentrically, and I never noticed when I tightened the chuck key up. However, almost, in fact it had actually gone through the full cycle, well not the full cycle, but it had gone through one cycle and it was just going to its second depth when I noticed, well, there was a problem. I knew there was a problem anyway before it got there because of the eccentricity of the teeth. But anyway, result was we ended up scrapping that one, and then the second one, unfortunately, due to me being a bit, I don't know, fussy, whatever, there was a little bit of flash left on after the final pass, so I cheated the system. I put the tool a little bit deeper into the not deeper into the holder, but further out from the holder, and let it cut the full cycle again. Unfortunately, there's some backlash in the system which I never noticed from the rotary, and it grabbed, and when it was doing the final tooth, it resulted in if I can find it, resulted in a real mess of this tooth here. As you can see, it just pulled it straight in and ripped it to pieces. So I'm going for aluminium because it's only a small job, and I've used a different technique. I'm using a waterline finishing technique this time. Before, I think it was a drive technique. Slightly different way of doing things. As you can see, it's taking a little bit at a time and it's doing each tooth separately. Last time it was doing it was going around it all the way around and dropping down in depth by small increments. Anyway, we'll see how it. Okay, well here we are again. As you can see, it's progressing quite nicely. The teeth, good shapes there. I'm leaving a 0.5 millimeter all around for finishing cut, so when this is done it'll go right round again and take my 0.5 millimeter off. It always fascinates me watching the table rotate and the milling table move back and forth to generate these curved surfaces. It's amazing stuff. Watch this. Just going to take one more cut. Oh, there we go. And bam. There you go. There's a bit of action. Oh, we're still making progress. The eagle-eyed amongst you, or the eagle-eyed machinist amongst you, will spot one one not so obvious thing to anyone that does CNC milling, but to anyone that's got a mill at home, a manual mill, they've probably noticed that this is climb milling. You wouldn't really attempt this on anything but a CNC machine or a very, very well adjusted manual mill that has very little backlash. I know I said yesterday backlash caught me out. It was the backlash on the rotary table that caught me out, and there's a process of eliminating this. You'll also say it's cutting air. That's probably because the plate is just a few thou wobbly here and there, and there should have been a few thou material left there to take off, but there isn't, so it's just cutting air at the moment. As you can see, it's just about on the last cut. I think maybe one more pass after this. Yeah, judging from the sound. It should go into the finishing finishing waterline phase next. I'm not sure if the machine will ask me for an input or whether it will just go straight into it, but we'll see. This is the last cut coming up now. We'll go over to the screen and we'll see. It should come through in a second now. Once it does this last tooth. Here we go. It goes back to here and may ask me to change tool, I'm not sure. It's same solid carbide end mill. Remove number 1 from spindle. When done, cancel to stop. So it's asked me for an input.